Alright, happy Friday, everyone. Sorry I haven't been here for a couple days. I'm sorry if you hear weird noises in the background. I just decided that my husband shouldn't be alone in the hospital and decided to join him, and had to have my appendix removed last night. So we're just two peas in a pod right now in the hospital. So hopefully I'll be back next Tuesday or Wednesday, but not quite sure when. So today's lesson is known as the natural logarithm. So remember that the other day we talked about the common logarithm, and the common logarithm is when something is base 10. Well, the natural logarithm is when something is base e. Okay, so once again, if you go on the left side of your calculator, you're going to see the word ln, and then right above it you'll see the word e to the x. Okay. So an exponential function whose base e is called the natural base, and then the logarithm with base e is known as the natural logarithm. Sorry, there should be an h in there too. Okay. So basically, we kind of abbreviate the way we write log base e. So log base e of x is the same thing as ln of x. Okay, it's just a short way to write log base e instead of having to write that every time. So notice that, e to the x, if I rewrote that, that would be log base b of x, and that is ln of x. Okay, so the property that we have for exponential and logarithmic functions, the inverse property, we can apply the same thing to the natural logs, because remember that natural logs are logs with base e. So we can say that when you take the natural log, the natural log of e to the x, you just get x. Think about why that is again. This is log base b of e to the x, and remember that if there's an exponent within a log, exponential function within a log, and the bases match, you get just x. Okay, and then same thing over here. If you have e to the natural log of x, that just equals x. Same concept here. E to the log base e of x, when you have an exponential function and there's a log with inside of it, these two quote-unquote cancel each other out, and you're left with just x. Okay? So once again, these properties are properties that you've already used. We're just applying them to the natural log now. Okay? So for example, when you have e to the natural log, they just undo each other, and this just equals 7. If you apply what we've been doing before, this is e log base e of 7, so that gets you just 7. Okay. Next example. If you have the natural log of e, these quote-unquote cancel each other out, or some students will actually physically just cross them out, and you get 4x plus 3. Okay, same thing, if we apply our properties from before, this is log base b of e to the 4x plus 3. These quote-unquote cancel each other out, and you're left with just 4x plus 3. Okay, alright, moving right along. All we're doing in this example is just writing equivalent expressions. So we've actually kind of already been doing it in the green up above. Okay, so we're going to circle the base, go to the value, equals the power. So log base e of 5 equals x. But we don't leave our answer like that. We're going to write it as the natural log of 5 equals x. Okay? Is it technically wrong if you don't switch the natural log, like write it as ln? No, but you should. Okay? So now we're going to go the other way. And sometimes students are like, well, wait a minute. There's no base here to circle on up. Well, remember that the natural log is the same thing as log base b of x. Okay? And now we do have that base to circle on up and rewrite as an exponential function. Okay? And now that you guys have your calculators, you can definitely test for that. Okay, so we have 3 problems to do, and that will be it for our work today. And notice that it says these problems do start on tomorrow's homework, meaning Tuesday's homework, but since today's lesson is pretty short, I think it's a good idea to go ahead and start looking at these today. So that way, especially if I'm not there on Tuesday, so that we have an idea of what we're doing already. Okay, so notice where the variable is in this problem. It's right here. Okay, and also notice in the directions it says that we need to do exact answers and rounded answers. So remember that exact answers in this situation are either going to have the word log in them or possibly just e in them. Rounded answers is after you plug it into your calculator. Okay, so I want to isolate e to the x. So just like I would with a normal algebraic equation, I would add 5 to both sides. And I get 2 to the ex equals 6. And then once again, this is not isolated yet, so I need to divide by 2. And I get e to the x equals 3. Okay? Now there's 2 ways you can approach this problem. Some students will like to switch into exponential form and go from there. So I'm going to put this one in the red because this isn't typically what I do. But they'll say, okay, log base e of 3 equals x. Okay, now you don't have log base e in your calculator in the sense of like using the word log. So then you guys switch this to ln of 3 equals x. And this would be considered your exact answer. Okay, I personally, to undo e to the x, I'm going to natural log both sides. Okay, and once again, the reason why I like doing this is, and this goes back to the video I made 2 days ago, the reason why I like doing this is because it makes the more difficult problems have the same pattern. Okay, so from this point right here, I'm going to natural log both sides. Okay, just to make sure that whatever you do to one side of the equation, you do to the other side of the equation. So now these two are going to cancel each other out, and you're left with just x equals ln of 3. Okay, and notice I got the same exact answer. Okay, and this is known as the exact solution. And to find the rounded answer, we're going to plug that into our calculators and get 1.0986. Okay, so let's jump over to number 3, and then we'll go back to number 2. So number 3, I'm going to do this over to the side a little bit because I kind of wrote too big on that part. In number 3, here's my e to the x. So just like a normal algebraic equation, I'm going to solve for e to the x, negative x, sorry, in this example. Okay, some students make the mistake here of natural logging both sides at this point, but this is what you have to isolate, and that's not isolated yet. So I need to divide both sides by 5. So I get e to the negative x equals 9/5. Okay? Once again, there's 2 different ways you could go about this problem. I like to go ahead and natural log both sides. Just make sure that whatever you do to one side of the equation, you do to the other side of the equation. These cancel each other out. And you get negative x. Remember the natural log on the other side. So natural log of 9/5. Okay. X is still not by itself, so I need to divide by -1. That -1 stays on the outside of the log. If you try to put it on the inside of the log, you get an error. Because remember that we can't take the log of a negative or 0 number. Okay? X is by itself, and my final solution for the exact, plug that into my calculator, and I should get approximately negative 0.5878. Okay? Alright, last example. Okay, I'm going to zoom in really big since I'm extra out of room on this now. Notice this time that we have the natural log, okay? We kind of want to think of it like a blockade. So we're going to start where the word we see ln is and go to the 3x. And that's what we have to isolate. How do we know the +1 isn't part of that? Because there's not parentheses. Okay? So the blue is what I need to isolate it. So I get 2 natural log of 3x equals 4. I'm going to switch to a yellow highlighter now. This is what needs to be isolated. So I'm going to divide both sides by 2. So natural log of 3x equals 2. Okay. And once again, there's 2 different ways you can do these problems. Okay. One is to remember the whole concept of when log equaling a number, we have to switch to exponential form. And I'm going to kind of stick with that way. So I'm going to rewrite this as log base e of 3x equals 2. And when a log equals a number, you circle on up. So you get e to the second equals 3x. And then x equals e to the 2 over 3. So once again, when a log equals a number, switch to exponential form. Okay. Now, if you go to the tutoring center, you ask your friends, they might do this problem a little bit differently. When you see the word ln, and once it's isolated, so you only see the word ln once, you technically, some people call it it, and you e both sides, and we apply the inverse property of logs. That cancels out. Sorry, let me make that a little bit better. This cancels out. The 3x is still there. So you get 3x equals e to the second, divide by 3, and notice you get the same exact answer. Okay? I just did it this way because this is, this sticks to the whole concept of when a log equaling the number, you have to circle on up. But if you go see a friend or the tutoring center, they might do it this way, and that's fine. Just make sure that you are down to 1 ln before you e both sides. You can't e individual terms over plus and minus signs. Okay? Once again, plug this into your calculator, and you should get 2.4630. Okay? Alright, I hope you have a wonderful day. Sorry, I just kind of took up a big portion of the period. And hope you have a great 3-day weekend. Hopefully I'll see you guys Tuesday or Wednesday. Thank you. Bye-bye.